Now we'll talk a little bit about the main core of the presentation today, which is how we leverage GIST for sustainable cities and urban planning. So first, I give you a little bit. If we could go to the first slide here, give you a little bit of an introduction into the problem of urban sustainability, right? Which is that in 2008, for the first time in human history, 50% of a large global population lived in cities. And the global population is still growing, maybe not quite as rapidly as it did in the earlier parts of the 20th century, in the latter 20th century. But by 2050, 70% of Earth's population will be living in urban areas. So the challenges we think of when we think of sustainability, things like preserving biodiversity, mitigating and adapting to climate change, while allowing for sustainable livelihoods and social equity, these are really challenges for planning, designing, and engineering cities, right? And so you see my little cartoon sketch here of what we call an urban metabolism, which is, how different physical and human systems in the city and natural systems relate, and how that changes the sustainability of the city overall, right? So you have soil resources in the city, you have an urban forest. What's the extent of the urban forest? Where is it located? How thick is the tree canopy? This affects the urban heat island. This affects how the city is cooled. This affects the hydrology of the city, how much water is recharged into groundwater, what kind of rain, flooding risk you have, and so on. But what are the industries in the cities? How can they be best linked into renewable energy? How do we basically redesign and reimagine the city so that it can be a little bit more circular? It can take care of more of its own wastes, maybe generate more of its own energy, so that as we're urbanizing the Earth, we're not putting as much burden, as much kind of urban footprint out against the whole rest of the globe and the ecosystems on the rest of the globe. So that's how we frame the problem of sustainable cities kind of broadly. Next slide, please. And so GIST is really key for leveraging solutions for these problems, right? We have an increasing number of satellites, especially small satellites now. And so we have a tremendous amount of data that we're harvesting about the surface of the Earth, about the kinds of activities that people are doing, ways of getting 3D models of cities that we'll talk about in the future, later, ways of looking at river systems in great detail, just a tremendous amount of data that's all, it's all can be geocoded. It all can be located to a point on the Earth through the global positioning system. And so this is a very powerful way of pulling data together to solve problems like urban sustainability. Next slide, please. And so, when we think about sustainability, we really want to think about the need to connect the local and the global. The old slogan for sustainability used to be, think globally and act locally. But I think what we realize now is that we need to both think and act globally and locally, right? Both globally and locally. And so the spatial provides this ability to connect across scales, which is really, really critical, right? So you can see here on the left in this image, nightlight giving us an accurate picture of GDP in China. We can think about the amazing urban development along the coast of China, and we can think about the ability to use remotely sensed data to understand the interaction of these cities spatially. Where are cities developing? How rapidly are they developing based on kind of these large scale interactions, right? And so, if the next urbanizing continent is Africa, we have that ability to understand the development of cities across the globe because we have access to this kind of remotely sensed data. And then we can go all the way down to a very local scale, like you see in the image to the right here. You can have, thinking about how we redesign the city block, right? In terms of, in Barcelona, for example, the effort is to say, take some blocks and group them together in what we call a super block, and very much reduce the traffic on the interior of the block, route the traffic more on arterial streets on on the outskirts of the block. This reduces people's exposure to near roadside air pollution. It provides a healthier and safer environment for people to walk in, to access parks and other kinds of resources. And so really we're kind of going through a rebalancing globally of our cities with the automobile and carving out space for things other than the automobile. And so that's all part of what we can do with GIS to understand the dynamics of those kinds of retrofits in our urban environments. So in the high income countries, we're really worried about climate change, we're worried about social equity, really worried about environmental justice. Again, GIS is absolutely critical there in terms of meeting the UN Sustainable Development Goals. In the low income countries, we're particularly worried about water, sanitation, hygiene, bringing fresh water, bringing sanitation. We're worried about air pollution. Again, these are the kinds of things that connecting the global to the local through GIST can really help with. Next slide, please. And so this power of GIST is really to couple human and natural systems in cities, right? And so you have some systems in the cities that are physical infrastructure, the things that cities have built and put in place in the city. There are other systems that are natural systems where where the rivers would have flown historically, where the opportunities for biodiversity are. And then there are human things too about where do people live and where are people living in the most dense patterns, where are different ages of people, where are people more vulnerable maybe to heat or pollution because they're elderly or because they're children. All of those things can be coupled together in GIST. And so this is really why it's so powerful for working towards urban sustainability. And not only can we couple the data together, we can actually bring, if you see here in this image to the left, GIS can be a system of engagement as well. We can bring the public into the process of thinking about how to make more sustainable cities. And it's so often the case that getting stakeholders from the public and from a variety of city agencies that are involved on the same page is what is needed. And our ability to visualize and our ability to make maps is a key part of that in terms of the power of GIST. Next slide, please. Okay, so just two quick examples here of how we actually use GIST in urban planning and urban sustainability. So this particular example here is use of it in transportation. This comes from the master's thesis of a student who got our MS GIST degree in 2016, Ben Suber. So he used something that's been developed, just in the last about 5-10 years called the Land Use Public Transportation Accessibility Index to look at the effect of adding a streetcar line in Tucson, Arizona. And what the Land Use Public Transportation Accessibility Index does, or LUPTI we call it for short, what that does is it looks at all the spatial data that's available now on different kinds of land uses, right? So where are the schools? Where are the banks? Where are the shopping centers? Where are different types of jobs? Where are entertainment venues? All those kinds of things. And then it pulls that together with network data on the transportation system to find out for any particular parcel in the city, any place where somebody lives, for example, a residential parcel, how accessible is that? How quick is it to get to a wide mix of destinations? And so then you can do what Ben did. When you develop that kind of a map of a city, then you can begin to make changes in the map. And so what Ben did was he put the new streetcar line in place, and he took away the bus lines that were deprecated when the streetcar went into place, and actually found something rather surprising, which is that the overall transportation accessibility of Tucson went down in spite of this streetcar investment, because the bus lines that were taken away were critical. And there was also a lot of continued development on the exurban sort of fringe of Tucson that wasn't being well served by transit access. And so he was able to show not only on average how the transportation accessibility of Tucson changed, but then also locate it, for example, in this map here, in specific parts of the city in terms of where transportation access went up and went down over time. So again, very dynamic ability to analyze and then perhaps present that back to stakeholders who may be surprised at the reality of what's going on in their city. Next slide, please. And then one other example, and this is a place where GIS is used for urban sustainability very extensively also, is making urban watersheds more sustainable. So the great problem of urban water is that we have built out systems for flood control. We very often send rainwater out to the ocean as fast as we can. This means that we have some risks of flooding. We have also very little recharge of our groundwater resources. And so what we can do with GIS is we can begin to look at the whole soil profile and environment profile of the landscape of the city. And we can find places where we can begin to let water stick around a little longer, constructed wetlands, where we can add infiltration basins, ways to bring water back into groundwater. And it's really, again, it's built on kind of layering data, right? So we know where the soils are appropriate for infiltration. We know where there are places where we can, maybe add a little constructed wetland because there's a vacant parcel. How would that all be kind of designed is all supported by GIST, really. Next slide, please. And so this is an example of the kind of beautiful outcomes that you get from this kind of practice, right? So this is a sponge city project in China that comes from a landscape architect there named Kang Jun-Yu, who has an enormous investment in and development of geospatial technologies. And you can see, for example, that in the dry season, there's an elevated platform that goes over the constructed wetland. And then in the flooded seasons, some of those elevated platforms might be closed, others might be elevated even higher enough that even in the worst flooding, they get kind of over that flooding, right? And so it's a way of providing a pedestrian connection. It's a way of doing groundwater recharge. It's a way of cleaning the water, because normally this water would have been maybe put into flood control infrastructure. It wouldn't have a chance to have any kind of natural vegetative treatment. But because of this beautiful park, the water has some time for the flora in the pond to do some of the water treatment. So it's a very advanced kind of practice. And we see this in Los Angeles. I don't have time to maybe give every example here, but in Los Angeles, for the Los Angeles River, we have this enormous planning effort now, which is really just depends on a lot of GIST, a lot of remote sensing, a lot of gathering of data by a spatial context to understand where the opportunities are to deploy one design or another. And you can see from this, right, that it's all very much 3D, right? If you're going to look at flooding, you have to understand where is the flood water going to rise? How high is it going to be? How much do we need to scoop out the ground? And so with that, I'd like to turn it over to Dr. Duan to tell us a little bit about advances in planning for a 3D world.
Thank you, Dr. Voss. All right, hi everyone. It's very happy to be here and talk to you about 3D, which is actually already a trend and already being applied a lot in planning in general. Next slide. Thank you. All right, so some of you probably have seen or used the BIM model in your life. If you have not, BIM stands for Building Information Modeling or Building Information Management. So BIM has been a very, very widely used technology in engineering, architecture, and building construction. So BIM basically allows you to look at, the building structure and in very detail, including that you can document the material that you use, for all kinds of things in BIM. So a lot of countries, for example, Singapore, and for example, Dubai, they have already made it a mandatory requirement that developer has to submit a BIM model when they are trying to submit their own plan proposal. So imagine that if you're a resident, if you're trying to look at the future zoning for your neighborhood, instead of looking at 2D map, now you can browse the 3D proposed plan for the entire country. So that's the goal. That's the thing moving forward. However, when you think about the connection between BIM and the large-scale modeling process, you can see there is a disconnection. When you're trying to put individual BIM model to its spatial context, we actually need to build a bridge between GIS and BIM, which is actually a trend now in architecture and building construction. So you can see that now with the connection between GIS and BIM, you can actually put individual detailed building models in like with its surrounding geospatial information. So if you're trying to run analysis on that specific model, you actually have all the data supporting your analysis from the surrounding neighborhood. Next slide, please. And another thing is when you think about how you use your Google navigation. Let's say if it's your first time on USC campus and if you're trying to figure out how can you get from where you are to a specific classroom on our campus. If you use Google navigation, that will cause you one problem. The Google app will only tell you the outside route, right? Where to get from the location of where you are and to that building of where your classroom is, and that's it. However, what happens if you actually want to know more about what's indoor look like, right? So how can you get from that building's entrance to that specific classroom you want? That's where we're heading with all the navigation. We actually have indoor routing applications now. And all these indoor routing applications, they are built upon GIS. So with the detailed building models that we just talked about previously, and on top of all the GIS information, we can easily combine those two information together and give you a very detailed and clear routing option from one specific location you're at to that specific classroom that you want to go to on campus. Next slide, please. And 3D techniques is not only used by just like private sectors of urban planning, they're also used by big agencies like FEMA. So FEMA has published a VR game. It's called Immersed. So when FEMA is trying to deal with educating people about what's going on in the future for your community, if a flood hits you, then if they're actually trying to use these kind of VR techniques to help them to show people what the scenario will look like and how you can respond. So imagine if you're looking at a 2D map again, or a bunch of documentation for your neighborhood to tell you if a flood hits, which route should you take? You have to sort of imagine all the scenarios in your head versus you can actually put on a VR goggle, and then you will see there is a virtual environment actually built based on your neighborhood structure. So basically you will see the virtual environment of your neighborhood inside of the VR goggle. And then you can run through all kinds of disaster scenarios. So what if an earthquake hits your community? What if there is a flood? What if there is a wildfire? How can you react? And which evacuation route should you choose? You can all practice those hypothetical scenarios in the VR goggle. Next slide, please. And the first Iron Man movie came out in 2008. So if you're a huge Marvel fan like I am, and back in the days when you were watching an Iron Man movie, you probably would have thought, well, that was super cool, right? When Iron Man is in his suit, he can see all kinds of information showing up on his screen right in front of him. And today we actually have those technologies available as well. So if we can click on the slide one more time, thank you. So with the help of VR, AR stands for virtual reality and augmented reality, and also mixed reality, we have those information available to us. So there are companies that are in Europe that they are actually trying to develop these windshield for cars. So in the future, when you're trying to navigate from location A to location B in your car, instead of looking at your phone or a screen in your car for the navigation route is going to appear on your windshield. So, and besides the navigation route, they can also show you the speed that you're driving, right? And the weather forecast for that location. So all those information are already available. Another usage for this kind of thing is think about the AR goggle. If you're a traveler to a new city, and if you wanted to find some places of interest, Again, instead of looking at your phone and trying to navigate yourself from where you are to that location, you can put on the goggle, and then you can see all the information right in front of you. So you can see, for example, where is our museum and how can you get from where you are to there. You can see all the, for example, gas prices if you're driving the car, all the gas prices around you. So when you think about how can we achieve all these cool applications, they're actually driven by GIS technologies. When you have a goggle, that's only the vehicle that you have, and you have to feed that vehicle with all the information. And all the information is actually generated with GIS technologies. Next slide, please. So when we were listening to Dr. Voss' presentation earlier, he mentioned something that's very important, which is sustainability, right? Today, we're seeing, unfortunately, the bad consequences of some climate change results. For example, we're experiencing worse and worse air quality at some places, and we're seeing the extreme heat results from some places as well. So, and one thing that we cannot deny is that we're going to see an increased population. How can we balance those two things, right? How can we have an increased population and at the same time have a very sustainable development pattern? So there are people that actually came up with this kind of idea that you're looking at on the screen. So what if I tell you that these two images are showing to you right now are showing the two proposals proposed by two unrelated companies at two different countries. So the left image actually shows a proposal that was proposed in Italy, and the right image shows a proposal proposed in China. Again, the two companies are not related together. However, they share the same concepts. So the concept here is that, yes, we can still accommodate high density population with a multi-family residential building. And on top of that, we can accommodate a certain type of green space in the building as well. So that is a very cool idea. So how can you visualize that idea is a great question, right? If you're the only person that has a great idea, however, you can't communicate with others, that is a big problem. So that is why we have all kinds of 3D techniques. Can we click one more time? Thank you. So with this type of software that is available right now, it is actually super easy for you to build 3D models at large scale driven by GIS data. And also you can visualize all kinds of scenarios, for example, forest inside of inside of buildings. Those kind of ideas, you can visualize that super easy. Can we click one more time? Next slide, please. Thank you. And at the same time, if we're looking at these kind of new design proposals, this new building is actually being proposed in London right now. So when you look at this building, it looks crazy at the beginning. However, when you think about the concept it's trying to propose, so this building is trying to propose this concept that the entire building is actually a city. So the entire building has all the things you will ever need if you're a resident living in that building. If you want, you can stay in that building forever. You don't have to go out. So if you look at the rendering of this proposal, we can see that this building actually contains all kinds of functions you will ever need, right? For example, retail and, for example, green spaces. You can actually have your indoor forest, indoor green space right there inside of the building. So again, if you have all these great ideas thinking about how you can change the world, how you can change how we live to be more sustainable, you need to be equipped with proper skills for you to be able to visualize and realize these kind of ideas. And GIS, and especially 3D GIS, is actually here to help you to make your life easier. All right, I'll hand it